Okay, electric circuits checkpoint 2, here we go. The key things on all these circuit questions really is not to try to force it. Let me just draw this across here. Don't try to force it, okay? Most of this is to do with V equals IR, and it's to do with R equals R1 plus R2 for series circuits, and 1 over R equals 1 over R1 plus 1 over R2 for parallel circuits, okay? This is really the only equations we need, but we need to be trying to apply them accurately. So calculate the total resistance of the circuit. We need to look at the circuit and work out that we can't do it all in one go, but we have got some resistors here. These resistors are all in parallel with each other, so we want to work out the equivalent to these ones first. So you do 1 over R parallel for the parallel section is 1 over 40 plus 1 over 20 plus 1 over 40. Okay, add those numbers together. You can do it as a fraction in your calculator, or if you're good enough with fractions, you can do that'll come out to 4 over 40. Classic mistake there is to say, oh, 4 over 40, that's 0.1. But remember, this is 1 over RP. So at the end, always write RP, therefore equals 40 over 4 equals 10 ohms. Don't be tempted to write equals 10 there, because that's really mathematically very bad and will get you into a mess, okay? Make the effort to turn it upside down and write RP equals that. So we want the total resistance of the circuit, so now we can get rid of all that, and we can imagine this circuit is a 10 ohm resistor that's replaced all of that lot, and a 50 ohm resistor, which we already had there. They're in series with each other, so that's our new circuit. So now we can say our total is 10 plus 50 equals 60 ohms. Okay, so our total resistance is 60 ohms. Calculate the current through the 50 ohm resistor. Well, again, the temptation for some people is to go I equals V over R. Look for a voltage they can find. Well, there's a voltage, 12. And then look for a resistance they can find. Well, there's one that's 50. But this 12 volts is not all across this 50 ohm resistor, because some of it is across here, okay? What you do have is you have that 12 volts across the whole resistance. So the current coming out of the battery is 12 over 60, which is 0.20 amps. But if you look at that, that current that's coming out of the battery is all going through that resistor and through that resistor. So that is the current going through the 50 ohm resistor. Okay, question 2. This one's a little bit trickier because it doesn't have any numbers. It all just requires you to do algebra. Okay, what you need to think here is I've got some current coming down here. Okay, I've also got some current coming down here. Now this current here is the same. So if we looked at IA, the current through A, and IB, the current through B, they would be equal. But in this case, IA and IB are not equal. They add up to the total current coming out of here, but they're not equal to each other. But we have got across here an EMF or a voltage of E, and the same there of E. So the voltages are equal, but the currents aren't. So the crucial formulas for us to know here are the power, and there's 3 equations for power, but the 2 that are relevant to us here are P equals I squared R and P equals V squared over R. So if you look at this circuit here, what we can say is the power dissipated by, just given out by A, is I squared RA. Okay, and the power given out by B is I squared RB. But it's told us in the question that in figure 1, A reaches a higher temperature than B. Okay, that means that PA, the power given out by A, must be more than PB. Okay, but the I's are the same, so the only way that can be true is if RA is bigger than RB. Okay, in the second circuit, this is for figure 1 here. For figure 2, right, then there's no point in us using this equation because the currents are different. We're going to end up with 2 unknowns in our equations. But in figure 2, we know that PA is V squared over RA, and PB equals V squared over RB. And we know the V's are E, they're both equal. Okay, so in this case, because RA is bigger than RB, we've already said from here, that means that PA will be less than PB, okay, which again is what it tells us because B gets hotter in that circuit. Okay, so quite a tricky one because a lot of algebra in there, but just be careful. If you think clearly, you can do all these questions. Okay, question 3 is a more sort of traditional question again. So here's our battery. We've got a circuit. In the first place, the circuit looks like this, but we're going to do different things in between X and Y. So the first thing we're going to do is short circuit X and Y, so that's just putting a wire there. If you put a wire there, all of the current is going to go this way around the circuit. This really becomes irrelevant as if it wasn't there, and that's just a wire, okay? You could prove that by doing the total resistance, but here you're going to have no resistance because we always assume in these circuits that the wires have no resistance. So you've just got 30 ohms, so this is a very straightforward question. V equals IR, so we're trying to work out a current. So we've got I equals V over R, 6 volts. Okay, we can do 6 volts because it's all over that resistor, so we've got 6 over 30, 6 over 30, 0.20 amps. Okay, very straightforward. 2 marks of that, it's very generous. In the second part, we've got a 30 ohm resistor in here, okay, so I'm going to just draw this out again here so you can see clearly what's going on. We've got a 30 ohm resistor there, we've got a 60 ohm resistor here, and then in parallel with that we've got another 30 ohm resistor. Okay, so we need to do the parallel bit first. So the resistance of the parallel section, 1 over Rp equals 1 over 30, 30 plus 1 over 60. Okay, that comes to 3 over 60. Again, don't be lazy. The parallel section is therefore 60 over 3 is 20 ohms. So the total resistance of the circuit is now the parallel bit, which was 20, plus the other bit, which is 30, gives us 50 ohms altogether. So to work out the current in the ammeter, now it's I equals V over R equals 6 volts across the total resistance of 50 ohms. Gives us a current of 0.12 amps. Okay, question 4. This one's getting quite tricky now because we've got 2 parallel sections, but there is a show that, so we're looking for 50 ohms as an answer. So if we go wrong, that will help us to see we've gone wrong. So we've got 2 parallel sections here. We've got to work those out one at a time. So for the first one, 1 over Rp equals 1 over 30 plus 1 over 60. We've just done this actually, is 3 over 60. Rp equals 60 over 3 equals 20 ohms. It's not too much effort to write that out, is it? And for the other parallel bit, 1 over Rp equals 1 over 40 plus 1 over 120. That comes to 4 over 120. So in this one, Rp equals 120 over 4 equals 30 ohms. So I've got 20 ohms and 30 ohms. So our total is 20 plus 30, 50 ohms. That's what they told us, so that's good. Okay, R1 down here, this is 50 ohms. Okay, write that information on the thing just to help you. So we're trying to find the current in R1. Well, we can do I equals V over R, but again, we haven't got 24 volts across here. There's 24 volts across the whole circuit. So that's 24 divided by the resistance of the whole circuit. Well, we've just proved that all this lot up here is 50 ohms. We've got 50 more ohms here. So the total resistance of the circuit is 100 ohms. 24 over 100, 0.24 amps. Okay, then this one's really hard. The current in the 60 ohm resistor. So to work out the current here, okay, we know we've got, put it on the circuit to help you out, we know we've got 0.24 amps coming around here. Okay, so part of that's going to go through there. Don't give me any of that ratio rubbish. I can't be doing with that. Okay, let's do it properly. So let's work out the voltage across that parallel section. Well, we know V equals IR, and we know the current through the parallel section in total is 0.24 amps, and we worked out the resistance of that bit here is 20 ohms. So we've got 0.24 times 20 is 4.8 volts. Okay, so if I connected a voltmeter here, it would read 4.8 volts. Sorry if that's a mess. Okay, I've got 4.8 volts across there altogether. But if I put a voltmeter here, let me try and just draw it a bit neater. If I try and put a voltmeter in there, this will also read 4.8 volts. Okay, so now I can look at this bit and I know I've got 4.8 volts across 60 ohms. So now I can do I equals V over R is 4.8 over 60 is 0.08 amps. Okay, and if you look at this number, okay, you've got a check there, haven't you? You've got 0.24 amps. 0.08 goes that way, 0.16 goes that way, okay? You can see that by ratios, but I just hate that method, okay? Just do it properly, go to basic principles, you can work it out.